So I'm going to teach you some of the very basic things about laminated glass. So in your vehicle, the front windshield's laminated. Lamination is two pieces of glass that typically has like a plastic material in between. So most times this is a PVB, polyvinyl butylene, I think is what it's called. And what the purpose of lamination is to give it a safety glass. So that inner layer stops all the UV from coming through the window, which is good from a heat transmission, and from you're going to get burned off of it and the staining of your fabrics and things like that. But you take the two pieces of glass, you cut them to the right size, you bend them or shape them however you want to, and now you've got two pieces of glass that you want to kind of bond together. So we're in what's called a clean room. This is put under immense pressure with lots of filtering on it, and that's because in between those two panes, you can't have it, like if a piece of hair falls in there, that piece of hair is going to be inside your windshield forever. So you get what's called PVB. That's stored in a refrigerator. Typically, 30 degrees or something like that. It's fairly cold. And it's stored in rolls. What we'll do before we actually go to make it into windshield is we cut it to size and you let it hang. That gets it all nice and flat. That way that you don't get any buckling or anything like that in between them. You lay down the two pieces of glass, you put the plastic in between the two, and then most times what you do is you put it under some sort of vacuum so that either sucks the air out between the two panes, or you run it through like a pinch roll, so like an old school washing machine, the two rollers, one on top and bottom. All you're doing is pinching that air apart. You vacuum that air out, make sure all the air is out of there, and then you put it under time and temperature in an autoclave, and that sort of cooks the PVB to the two pieces of glass. And then this is an autoclave. This is a really small one, but it's probably 10 foot tall, 15 feet deep. The really large industrial ones where you make lots of windshields, those might be almost 20 feet tall and sometimes 60 or 80 feet deep. So these are massive, but think about them the same as you would like a pressure cooker that you make chicken in or something like that. You're gonna put all of those glass sandwiches, the two pieces of glass, the PVB that have been vacuumed out, you put them in here on racks, and then you ramp this thing up to time and temperature. So it might go up to say 200 or 300 degrees, and then you put it under X amount of pressure, and then you leave it sit there for 4 hours, 8 hours, 12 hours. It varies depending on a bunch of different things. But once it goes up in time and temperature and allows that PVB to kind of cure, it turns from that opaque color that we saw to a transparent color, and it bonds really well to both pieces of glass. So that's essentially how you make laminated glass. So this is an example of how we bend the glass. So these are different sorts of frames. You can tell one is kind of the top and one is kind of the bottom. And you can put these in what's called gravity furnaces. So essentially you put the glass that's cut to that size, and as you put it through a furnace, what happens is the glass kind of slumps into that shape. And you can also have other things called press furnaces. And instead of just allowing the glass to kind of heat up and then gradually, slump into that shape, the presses actually are a mechanical push. Once the glass is kind of molten enough that it's pliable, you can bend into that shape, and then when you cool it quickly, it locks it into those shapes quicker. So that's really how most of these glass shaped processes are done. There are some that as you put them through, there's kind of blast heads that curve, and the variable cooling rate that you put on the glass will make one side cool quicker than the other, which that will also kind of curl up the edge. But most shaped glass is actually done through either a gravity or a press process. And this is an example of what a tempering furnace might look like. So you can see these are nice flat parts. Sometimes, again, they're used with those gravity or press bend shapes, but most of our customers in architectural just do flat tempering. So what you do is you take a flat piece of glass that's cut to the exact size that you need, you put it up on this roller bed. As it goes through temperature, you have different types of rollers. There's Kevlar rollers, there's stainless steel rollers, and a variety of things. But all you're looking at here is this long roller furnace. What happens is you heat the glass up to maybe 1300 degrees Fahrenheit, and then you cool it down really quickly with a series of massive blower heads. These blowers, typically, you have 2,000 horsepower motors that turn these massive volume of air movers. And what you're doing is you're cooling the glass down quickly from that 1200 degrees down to room temp, maybe in 90 seconds, really, really quickly. And what that does is it locks in the surface into compression, and it balances the body of the glass to have a lot of tension in the middle. So what that quick quench does is it makes tempered glass. Well, tempered glass, what happens is when you break it, it shatters into a million pieces. That's because when you cool it so quickly, that compression that's on the surface is really keeping that surface really high impact resistance, and it's really making it very strong. But when it does break, all that tension that's in the center needs to blow out and stress relieve, and that's what causes it to break into thousands of tiny pieces.